Okay, so if we take, let's say we have a line, and we'll just call this line, so we'll call it A. So this is the line A. Now, if I want to square this line, so let's say A squared, what does that actually look like? So what I'm doing is I'm taking this line and I'm actually turning it into a square. So it looks something like this. So this is A squared. And then if I wanted to cube it, I turn it into a cube. So when we talk about squaring, okay, or squares, this is essentially what we mean. We're taking whatever it is and we're turning it into a square. So let's say if I was to take the number, so 2. So imagine I have a line and it's just 2 units, so something like that. Now if I want to square this, so 2 squared, you're going to take this line of 2 and you're going to split it up into 2. So you're going to make a square out of it and then you're going to divide it up into 2. So it'll look something like that. So how many spaces has it got then? So it has 1, 2, 3, 4. So, and as we know, 2 squared is equal to 2 by 2, which is equal to 4. So this is what 2 squared actually looks like, and this is what it looks like visually. Now what we can do is we can take this same principle and we can apply it to a little bit more complicated maths. So if we take something like this, so if we have a plus b to be squared. Now you may have learned that like this to be squared is equal to a squared plus 2ab plus b squared. So all you do is you take this and you multiply it out. A plus b, a plus b, that's what it means. So you're multiplying this by this, this by this, this by this, and this by this. But the question is, why is it this way? Okay, and what does this look like visually? So what we can do is we can actually um, represent this guy here visually, and we can actually show this as well in a more visual way. So let's have a look at this. So the first of all, what we want to do is so this here, this it means to the power 2 or square. So what does this look like here? A plus b squared. So we have a square and it has lengths of a plus b. So we can write something like this. Let's just take this, bring this down a little bit so that we can work with this. Okay, so what we have here then, we have a visual representation of this term here. And let's just have a look at that and work through this one. So a squared, so a plus b to be squared. So this here, this whole shape here represents a plus b to be squared. So this whole shape, all of these parts together give us a square that represents this. So if we think about it, so we have, so this length from here to here is called a plus b. And then this length from here to here is called a plus b. And then all we're doing is we're just multiplying them by each other. So a plus b multiplied by a plus b, this is what it's equal to, a plus b squared. Now, we've worked out here that a plus b squared is equal to this. But what does that look like? So let's look at all of these terms. So a plus b squared is equal to, so all we're basically saying is that, so if we take, like, where is a squared in this square? Well, so let's say, so it's equal to a squared, so a squared is this square that's within this bigger square. Okay, so that represents a squared. Plus 2ab, so plus 2ab. So ab, where's ab? Well, if we have a look at here, for example, so this rectangle here is a by b. So this here is ab, and this up here is also ab. We have two of them. So ab. So hence, that's where this 2ab comes from. So we've two of these here. And then we're left with the last bit, which is plus b squared. So where is b squared? This is b squared here. B squared. So again, this is where, like, if we take something like this, we can actually map this out visually, and this is what it looks like. And then we can break this down. So this is what this looks like visually as well. So hopefully that makes sense. And that's where it comes from. That's where the idea of squaring actually comes from.